Welcome to educator.com. In this lesson, we will be working on solving inequalities by adding or subtracting. In this lesson, you will learn to solve inequalities by using inverse operations such as addition and subtraction. Applications are for finding the maximum number of people an elevator can hold. Vocabulary for this lesson is the addition property of equality and subtraction property of equality. You've already seen these properties when solving equations. Basically, the addition property of equality says that when you add the same number on each side of an inequality, the relationship between the two sides does not change. You would use this property to cancel out subtraction operations. The subtraction property of equality tells you that when you subtract the same number on each side of an inequality, the relationship between the two sides does not change. You would use this property to cancel out addition operations. So if I had x is greater than 7 and I wanted to use the addition of property of equality, I could add 2 to both sides without changing the relationship. X plus 2 is greater than 9. Next, we could go down the subtraction property of equality and get rid of this addition here and subtract 2 from both sides. X is greater than 7. So notice we've returned to our original x is greater than 7. By adding the same number to both sides, then subtracting the same number to both sides, we have not changed the relationship between x and 7. Let's try solving some inequalities by adding. First off, we're going to solve this equation to show us how solving equations is pretty much the same as solving inequalities. X minus 8 equals 10. If you remember from solving equations, we're going to look at the side with the variable, the left side, and look for the operation, which is subtract 8. And now we're going to do the opposite, which is add 8. 8 minus 8 cancels out to 0, and we've isolated x, which equals 18. Next, we're going to solve x minus 8 is less than 10. And now we'll add 8 to both sides, and x is less than 18. So you'll notice the steps in solving an equation and solving an inequality are basically the same. Let's solve some more inequalities by adding. Once again, we're going to look for the side with the variable, which is the left side, and we're going to do the opposite of subtract 5, which is add 5. That cancels, and we've isolated t, and 2 plus 5 is 7. In algebra, the variable is usually written first, and this will also help you later on with graphing. So let's turn this around. 7 is less than or equal to t, so that means t is greater than or equal to 7. So let's make sure that our symbol switches around too when we switch our sides here. Next, a minus 8 is greater than 15. The opposite of minus 8 is to add 8. A is greater than 23. Let's solve an inequality by subtracting. We're going to have to first translate the word problem into an inequality that we can solve. A bus can carry at most 80 students. If 23 students are on the bus, how many more can board the bus? So we already have 23 students on the bus. Some more students are going to board. Add some more students. And at the very most, it's going to be 80. So it's either going to be less than or equal to 80. It can't be more than 80 because they won't fit on the bus. So the opposite of adding 23 students is subtracting 23 students. And S is less than or equal to 10 minus 3 is 7. We borrowed, so 7 minus 2 is 5. 57. So how many more can board the bus? 57 more students can board the bus. It doesn't have to go all the way up to 57, but if we need to fit as many people on as possible, it could fit 57 more. A theater can hold at most 400 people. So far, 106 tickets have been sold for a recital. Write and solve an inequality to find out how many more tickets can be sold. So far, we've already sold 106 tickets, and we want to sell more. We want to sell as many as we can. So how many more tickets can we sell? But we know that the theater can hold at most 400 people. So we've got to sell less than or equal to 400 tickets. Otherwise, the people will not have a seat. The concert will be sold out, or the recital will be sold out. So the left side is the side with the variable, and we're going to subtract 106, take out the 106 tickets that have already been sold. That cancels to 0. We've isolated the tickets. 10 minus 6 is 4. We borrowed, so 9 minus 0 is 9, and we borrowed 3 minus 1 is 2. So 294 more tickets can be sold before the theater is sold out. Solve the inequality 17 is less than or equal to t minus 12. So I'm going to find the side with the variable, which is the right side, and I'm going to do the opposite operation, the inverse of subtracting 12 is going to be adding 12. And we've isolated t, and over here we have 29. And remember that in algebra, it's best to write the variable first. And we want to make sure that if we're flipping t over to the left side, we want to keep our symbol open to t. T is greater than or equal to 29. 8 is greater than or equal to 3 plus m. Now remember that the sign that goes with the number is in front. This is a positive 3. So the opposite of positive 3 is to subtract 3. And that will cancel, and we have m is less than or equal to 5. And if I want to write it in algebraic form, which you should, we're going to put m in front and keep it less than or equal to 5. So the closed side is facing m, so the closed side is still facing m. M is less than or equal to 5. Your parents give you $50 for an MP3 player that costs at least $200. Maybe you want to buy a nicer one that's more than $200. But at the very least, you're going to need to have $200 to go to the store to get an MP3 player. Write and solve an inequality to find the amount of money you have to save to buy the MP3 player. So you already have $50, and you need to save S more dollars. S for save. And at the very least, it should equal 200. So it can equal more than 200, but at the very least, it should equal 200. So what we're saying is you could save more than $200 and go to the store with more than $200, but you could also equal exactly $200 and be able to buy the MP3 player. So we've written the inequality, and now let's solve it. Subtract 50, subtract 50. And you still need to save $150. Maybe you will save more and you'll be able to get a nicer one. But at the very least, you need to save $150. During the summer months, a town restricts the water each household uses to 200 gallons of water per day. One day, a family uses 45 gallons for bathing, 20 gallons for laundry, and 25 gallons for cleaning. How many gallons can the family use to water the garden? Well, first let's find out how much the family has already used up. For bathing, 45 gallons. For laundry, 20 gallons. And for cleaning, 25 gallons. So the family has already used up 90 gallons. And we know that at the very most, the city is allowing the family to use 200 gallons. So 90 plus water not used, so maybe water left over, has got to be less than or equal to 200. It can at the very most be 200, but it would be better for the city if it was less than 200. Now let's subtract the 90 that's already been used to find out how much is left over. And 110 gallons are left over. So if the family wanted, the family could use 110 gallons to water the garden. So we've written the inequality here and solved it to find how much water is left over for the garden. And we've also answered this question, how much water was used for bathing, laundry, and cleaning? 90 gallons. It's a good idea after you've finished a word problem, especially a longer one, to go back and read all the parts of the question and make sure that all the parts of the question have been answered. Thank you for watching Educator.com.